Have you ever wondered why some cars become legends while others are just transportation? Here's the thing, most people think they know the answer. Speed, exclusivity, a famous badge. But what if I told you the car that arguably defined the modern supercar era was never supposed to exist as a road car at all? What if the vehicle that changed everything we thought we knew about performance, handling, and driver danger was built almost by accident, rushed out the door by engineers who were genuinely terrified it would destroy people, and kept secrets so strange that the company tried to bury them for decades? You probably think the 1975 Porsche 911 Turbo became famous because it was fast, exclusive, and brutally expensive. And sure, those things are true. But if you walked away thinking that was the whole story, you would be missing something far more fascinating, far more dangerous, and honestly far more human than any spec sheet could ever tell you. What you did not know is that this car was so unpredictable, so violent in its power delivery, and so revolutionary in its engineering that it did not just change sports cars. It rewrote the rulebook entirely. In the next few minutes, you are going to discover 20 weird, wild, and genuinely surprising facts about the 1975 Porsche 911 Turbo that even the most obsessed Porsche fanatics have never heard. And I promise you, one of these facts is so bizarre, so completely unexpected, that Porsche spent decades trying to keep it quiet. We are talking about a birthday present that predated the official launch, a gearbox deemed too fragile for the engine's own violence, a compression ratio so low it barely outperformed a lawnmower, and a whale tail spoiler that was secretly keeping the engine alive, not just the car planted. This is legacy motoring, and I spend way too much time thinking about what makes certain machines transcend their era and become something close to mythology. If you are someone who lives for deep-dive automotive history, the kind of stories that go way beyond horsepower numbers and 0 to 60 times, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Now, before we get into the wild stuff, let me set the scene. October 1974. Paris Motor Show. Porsche rolls out what they describe as a production sports car. The crowd leans in. Journalists reach for their notepads. And somewhere in the back, Porsche executives are quietly sweating through their suits because they are not actually sure anyone is going to buy this thing. The Turbo was never meant to be a flagship. It was not even supposed to be a long-term product. It was a homologation special, built purely to satisfy Fédération Internationale de l'Automobile rules that required a minimum of 400 street-legal units before a racing variant could compete. Porsche figured they would reluctantly sell those 400 cars to wealthy collectors, check the box, and go racing. Then something happened that nobody at Porsche predicted. The orders flooded in so fast that engineers who had been planning to wind down production suddenly had to completely reorganize the factory. Road testers reported that passengers were involuntarily grabbing the dashboard when the Turbo kicked in. One German magazine famously wrote that the Turbo could make atheists believe in God, because only divine intervention could explain surviving the acceleration. That kind of response does not happen by accident. It happens when you build something that genuinely shocks people, something that crosses the line from performance car into a different category altogether. And the 1975 Turbo did exactly that, fact after fact, detail after detail. So let us get into it. Let us start with the engine, because understanding what Porsche actually built under that whale tail is the key to understanding everything else. The 3.0-liter flat-six at the heart of the original Turbo ran a compression ratio of just 6.5 to 1. Read that again. 6.5 to 1. In an era when high-performance engines typically ran 9 or 10 to 1, Porsche deliberately built their flagship with compression so low it was barely above agricultural equipment. Now, you might be thinking, why would the engineers behind one of the greatest sports cars ever made do something so counterintuitive? Here is what most people do not realize. The single KKKK 3LDZ turbocharger could generate boost pressures that would destroy a normal engine within seconds. Remember, this was before computers controlled anything. There were no knock sensors, no adaptive timing maps, no electronic safety nets of any kind. The fuel available at service stations varied wildly in quality, and premium unleaded was still a fantasy in many markets. European pumps might deliver 98 octane one day and 95 the next. American fuel was even less predictable, with some stations selling gasoline that would make a modern engine management system have a complete nervous breakdown. The ultra-low compression ratio was Porsche's insurance policy against detonation, that engine-killing phenomenon where fuel explodes instead of burning in a controlled fashion. And here is the beautiful side effect of that choice. It created the turbo's legendary personality. Below 3,000 RPM, the car felt almost broken, struggling to pull away like a sick Volkswagen. Then you would hold your nerve, keep your foot down, watch the tachometer sweep past 3,500, and physics would seem to break entirely. The turbocharger would suddenly wake up and the car transformed into something else completely. The acceleration was not linear like a normally aspirated engine. It was exponential, building on itself like compound interest, surging forward with a violence that road testers struggled to put into words. Contemporary journalists reached for phrases like being rear-ended by a freight train or strapped to a missile, and even those comparisons felt inadequate once you had actually experienced it. 0 to 60 times varied wildly in period tests, anywhere from 5.5 seconds to under 5, depending on temperature, altitude, driver skill, and frankly how brave the person holding the stopwatch was. What every single tester agreed on was the 30 to 70 miles per hour acceleration, the range where the turbo lived in its sweet spot. In fourth gear, burying the accelerator at 30 miles per hour would trigger an explosion of speed that embarrassed contemporary supercars costing twice as much. This was not just acceleration. It was teleportation with a soundtrack. Now here is where it gets really interesting, because Porsche's engineers knew that compression ratio was only half the battle. The other half was keeping everything together when the boost arrived. The bore and stroke of the 3-liter engine measured 95 mm by 70.4 mm, dimensions that came from reworking the earlier 2.7 but involved far more than a simple capacity increase. Every single internal component was reimagined for a life under boost. The 95 mm bore pushed the limits of the magnesium crankcase, leaving minimal material between cylinders. Engineers knew that boost pressure would try to lift the heads off the engine, split the case apart, and generally turn precision engineering into expensive scrap metal. The solution involved forged pistons built to handle enormous cylinder pressures, strengthened head studs that clamped everything together with significantly greater force than the standard engine, and comprehensive oil cooling upgrades designed to survive sustained boosts. The 70.4 mm stroke was deliberately short, producing what engineers call an oversquare configuration. This helped the engine rev freely despite the turbocharger's rotational inertia, and the oversquare design also provided more valve area for better breathing, which matters enormously when you are cramming compressed air into cylinders at elevated pressure. The forged connecting rods were shot-peened for strength, a process that bombards the metal surface with tiny steel balls to induce compressive stress and dramatically improve fatigue resistance. The crankshaft was nitrided, a heat treatment process that hardens the surface layer while leaving the core tough and ductile. Even the valve springs were upgraded to handle the increased cylinder pressures without floating at high RPM, a phenomenon that causes the valves to stop following the camshaft and opens up the possibility of catastrophic engine damage. Oil cooling became absolutely critical with turbocharging, and this is where Porsche's experience with the 917 racing program paid enormous dividend. The standard 911's simple oil circulation system was never designed for a world where exhaust temperatures could exceed 1,000 degrees Celsius continuously. Porsche added a front-mounted oil cooler and significantly increased oil capacity, essentially converting the engine to a more sophisticated dry-sump lubrication design capable of handling genuine track abuse. The turbocharger itself presented packaging nightmares that consumed months of engineering time. It generated heat like a blast furnace and needed its own dedicated oil supply for bearing lubrication. High-pressure oil lines had to be routed through an engine bay that was already packed beyond reasonable capacity, snaking past fuel lines in arrangements that made safety engineers deeply uncomfortable, protected only by carefully designed heat shielding and millimeter-precise routing. Every surface under the engine lid served multiple purposes simultaneously, providing structure, managing heat, and packaging components into a space that the original 911 designers in the early 1960s could never have imagined containing a turbocharged power plant making this kind of power. Look, the fuel delivery system that managed all of this was equally fascinating and equally unforgiving. The 3-liter turbo used Bosch Cagetronic mechanical fuel injection, a system that had no electronic brain, no sensors communicating with each other, and absolutely no safety nets of any kind. Instead of computers making thousands of calculations per second, the Cagetronic worked through a purely mechanical symphony. A large airflow meter plate moved up and down based on how much air the engine was inhaling, and this physical movement directly controlled a fuel distributor that sent pressurized gasoline to the injectors. No electronics, no calculations, just pure mechanical cause and effect operating at speeds and pressures that demanded perfect calibration. For a turbocharged engine, this created unique and demanding challenges. There was no intercooler on the 3-liter turbo, which meant the compressed air entering the engine could be genuinely scorching. Hot air is less dense than cool air, requiring less fuel for the correct mixture, but the mechanical system had no way to compensate for temperature variations. Porsche's engineers had to calibrate the system for worst-case scenarios, which meant the engine frequently ran richer than necessary under normal conditions. Intake temperatures mattered enormously during hard driving, and experienced owners learned that a turbo driven hard on a cold winter morning was a genuinely different animal from the same car pushed to its limits on a hot summer afternoon. The mechanical injection also meant there was no electronic boost control, no knock sensors scanning for dangerous detonation, and no safety algorithms ready to pull timing and fuel if things started going wrong. When you pressed the accelerator, you were directly controlling a mechanical pump that would happily deliver enough fuel to damage pistons if the driver was not paying attention. It was analog performance at its most raw, most unfiltered, and most demanding. And then there was the gearbox situation, which tells you everything about just how extreme this car was considered to be by its own creators. Porsche chose a 4-speed transaxle for the turbo at a time when choosing 4 speeds for your flagship sports car was like showing up to a gunfight carrying a knife. The contemporary Carrera already offered a 5-speed gearbox, and even mainstream economy cars were starting to offer 5 ratios as standard equipment. So why did Porsche deliberately go backwards? Here is what most people do not realize. Engine torque and boost spikes were judged too brutal for the contemporary 5-speed unit. Think about that for a moment. The engineers who built cars capable of surviving 24 hours at Le Mans decided their street car was simply too violent for their best available transmission. The 4-speed Type 930 gearbox was essentially a racing unit crammed into a road car. First through third gears used straight-cut teeth, which created the distinctive whine that turbo owners either loved passionately or found deeply irritating depending on their temperament. The gear ratios were spaced like a drag racing application, with a tall first gear designed to help prevent wheel spin on launch and subsequent ratios carefully chosen to keep the engine spinning within its narrow effective power band. Porsche reinforced every component in the assembly. The input shaft was made thicker, the synchromesh rings were built stronger, and the limited slip differential was engineered to handle launches that would twist a conventional gearbox into modern sculpture. And there was another advantage that Porsche never officially advertised. With fewer gear changes required to reach any given speed, drivers had more time to focus their attention on not crashing. Because when the boost arrived in a 930, you needed both hands firmly on the wheel, your eyes locked on the road ahead, and every available brain cell dedicated to managing what was happening beneath you. The 4-speed was not a compromise. It was a survival tool disguised as a gearbox. And Porsche never fitted the later 5-speed until the final year cars rolled off the line in 1989, creating one of the longest-running deliberate decisions in sports car history. Experienced 930 pilots developed an entirely different driving technique around this limitation. They would brake later than seemed reasonable and carry more speed through corners, knowing that getting back on boost after a speed reduction took precious time that could not be recovered. They would short shift to keep the turbocharger spinning, rather than letting it wind down and face that agonizing wait for boost to return. They traded optimal gear ratios for immediate throttle response, making driving decisions seconds ahead of where a naturally aspirated car would require them. It was like conducting an orchestra where the brass section had a 3-second delay built into every note. You had to plan your music before the musicians were ready to play it. But when everything came together perfectly, when a skilled driver nailed a heel-and-toe downshift and caught the boost at precisely the right moment in precisely the right corner, the 930 delivered an experience that no modern car with its electronic interventions and instant torque can ever replicate. The sudden violent transition from almost nothing to absolutely everything, the way the rear suspension compressed hard under acceleration as if the car was gathering itself before a leap, the whistling shriek of the turbocharger building speed, all of it combined into automotive theater of the highest and most dangerous order. Now, you might be thinking that the engineers must have done something to make all this power manageable, some clever chassis work or suspension magic to keep drivers alive. And the answer is yes, they did, though manageable is perhaps not quite the right word. The brake system on the 1975 Turbo drew directly from knowledge accumulated during the 917 racing program, and the connection was not marketing language invented after the fact. It was a genuine engineering lineage. Porsche's legendary endurance racer had taught their engineers lessons about heat management, fade resistance, and component durability under sustained extreme conditions that no road car program could have generated independently. The 917 could reach 240 miles per hour on the Mulsanne straight at Le Mans, then brake impossibly hard for the tight chicane, lap after lap, for 24 consecutive hours. That accumulated knowledge transferred directly into the street turbo's brake specification. The brake discs were internally ventilated and cross-drilled, featuring a design that looked almost too beautiful to serve a functional purpose but existed entirely for serious engineering reasons. The holes helped dissipate heat and allowed gases that could cause brake fade to escape, while the internal vanes pumped cooling air through the disc like a centrifugal fan running continuously at road speed. 4-piston aluminum calipers grabbed these discs with authority that made contemporary sports cars feel dangerously underbraked by comparison. But Porsche's engineers did not stop at the obvious components that journalists and buyers would notice. The wheel hubs were substantially strengthened to handle the increased forces generated by wider tires and more aggressive cornering load. Brake lines were upgraded to reduce expansion under the higher pressures the system could generate during hard stops from high speed. Even the brake fluid reservoir was enlarged, because the engineers knew that owners with track day ambitions would boil through fluid at rates that would leave a standard reservoir embarrassingly empty. The master cylinder came directly from Porsche's competition parts inventory, delivering firm pedal feel and progressive modulation that rewarded drivers who learned its characteristic. This was not a brake system engineered to meet minimum legal safety standard. It was a system designed to allow drivers to genuinely explore the turbo's performance envelope without the creeping fear that the anchors might give up before the speed did. Here is where it gets really interesting, because the visual element that made the turbo instantly recognizable was doing far more work than anyone standing on the pavement admiring it could possibly have guessed. Those massively flared rear fenders, 12 centimeters wider than a standard 911, were more than just the most dramatic styling statement Porsche had ever made. They represented a fundamental philosophy shift at Zuffenhausen, a public acknowledgement that form and function could produce something spectacular when pushed to their logical extremes simultaneously. The engineering reason for the extra width was straightforward enough. More rubber on the road meant more grip, and more grip was quite literally the only thing keeping turbo drivers from becoming cautionary statistics in motoring journalism. But the execution elevated functional necessity into something approaching art. The flares were not tacked-on additions bolted to standard bodywork as an afterthought. They were sculpted into the body with a fluidity that made them look inevitable, as if the car could never have existed in any other form. Each flare was hand-formed by craftsmen who understood they were not just making panels but creating visual statements that would define a generation of sports cars. The black stone guard foils fitted ahead of the rear arches from new were a practical touch that became an unlikely signature styling element. These rubber strips prevented stone chips from destroying the paint in the vulnerable area where the wide tires could throw up road debris, but they quickly became as recognizable as the whale tail itself. Many owners removed them in pursuit of a cleaner, more integrated look, then quietly reinstalled them after their first drive on a road with loose surface material. The extra width changed the turbo's visual presence in ways that photographs still struggle to fully capture. Viewed from directly behind, a standard 911 of the period looked almost delicate, its narrow haunches suggesting refinement over aggression. The turbo looked like it had been spending serious time in the gym, its wide rear stance communicating purpose, and barely contained force before the engine even started. The extra width created practical challenges that owners navigated with varying degrees of patience. Multi-story car parks became exercises in spatial awareness that some turbo owners simply refused to engage with, parking on the street regardless of weather rather than risk scraping those hand-formed fenders on a concrete pillar. Narrow European streets that a standard 911 could navigate with casual ease became threading-the-needle experiences requiring concentration and commitment. Some municipalities actually had regulations concerning maximum vehicle width that the turbo technically violated, though enforcement was essentially non-existent. After all, who was seriously going to issue a parking citation to something that looked like that? The aerodynamic work that accompanied the wide body was equally serious and equally misunderstood by casual observers. That giant rear wing, the original whale tail that became the car's most recognizable feature, was doing something that its elegant organic shape disguised completely. Wind tunnel testing had revealed that the standard 911 body generated dangerous levels of aerodynamic lift at the speeds the turbo could achieve. A car capable of exceeding 155 miles per hour in standard trim needed aerodynamic intervention that went beyond cosmetic adjustment. The whale tail did not merely reduce lift in the way that most people assumed. It actively created downforce, pushing the rear wheels into the road surface at exactly the point where all that turbocharged power needed traction most desperately. Porsche's engineers discovered something else entirely during testing that never appeared in any press release or owner's manual. The spoiler's shape created a low-pressure zone that actively extracted hot air from the engine compartment. On an air-cooled engine running sustained boost pressures that generated enormous heat, every single degree of additional cooling represented meaningful protection against catastrophic failure. The whale tail was simultaneously keeping the car planted at speed and keeping the engine alive under load. Some owners removed the spoiler entirely in pursuit of a cleaner, more standard 911 appearance, then reinstalled it with considerable urgency after their first high-speed motorway run. Without that wing-generating downforce, the 930's rear end would become progressively light and wandery at velocities where stability was not merely desirable but genuinely critical to survival. The whale tail was not optional equipment in any meaningful sense. It was a structural element of the car's safety system, disguised as a styling statement. And here is the detail that most people completely overlook even after years of turbo ownership. The original whale tail fitted to 1975 cars was actually more visually elegant than the later T-tray spoiler that arrived in 1978 with the 3.3-liter engine and its intercooler. The original had a subtle integrated lip that flowed naturally from the engine cover with a sculptural quality that the wider, more aggressive later version sacrificed in favor of function. Collectors who know their turbos will pay significant premiums specifically for the original whale tail configuration, recognizing something in its proportions that the later version, despite being technically superior, simply does not possess. Now let us talk about something that reveals just how much Porsche underestimated what they had created, because the production numbers from that first year are genuinely shocking when you put them in context. Total 1975 turbo production reached just 284 units. Not 400, not 1,000, not the kind of numbers that support the infrastructure of a serious production car program. 284 cars, each one spending weeks in production with ongoing engineering tweaks applied across what Porsche designated the H-Series build run. These were not vehicles rolling off an assembly line in the conventional sense. Each turbo was essentially hand-assembled by Zuffenhausen's most skilled technicians, people who understood that they were building something that existed outside the normal categories of road car production. Panel gaps were adjusted by eye and by feel rather than by fixture and gauge. Engines were run on dynos and listened to carefully for any irregularity that instrumentation might miss, but experienced ears would catch immediately. Paint finishes involved multiple stages of hand sanding and polishing that would be economically impossible on any modern volume production line. The build process resembled race car preparation far more than automotive manufacturing, and the results reflected that approach in ways that owners felt every time they drove. Running changes appeared throughout the build run as engineers identified improvements or resolved issues discovered during production. A clearance problem that emerged on one car might be solved with a custom fabricated bracket that appeared on every subsequent example. An oil line that showed signs of chafing against an adjacent component would get a specially designed protective guard from the next car forward. These continuous improvements mean that no two 1975 turbos are exactly identical, a fact that drives restorers and authenticity judges to considerable frustration but gives each surviving car its own individual character. Here is something that Porsche's official history glosses over with careful vagueness. Every single first-year turbo left the factory with the steering wheel on the left side, regardless of its intended market destination. Not a single right-hand drive example was produced, leaving British, Australian, and Japanese buyers who wanted the ultimate Porsche with a stark choice. Either adapt to driving a left-hand drive car on roads designed for traffic flowing in the opposite direction, or wait for a configuration that did not yet exist. Many chose to adapt, creating the memorable situation of some of the world's most exclusive addresses featuring German supercars navigating the wrong side of the road with varying degrees of elegance. The reason was not anti-British sentiment or manufacturing arrogance. It was simple commercial logic rooted in Porsche's fundamental misreading of the car's market potential. Setting up production tooling and processes for both steering configurations would have delayed the project and consumed significant capital investment for what the company's planning department confidently predicted would be a short, limited production run. Why spend money on right-hand drive infrastructure for 400 cars? The irony embedded in this decision is almost too perfect. Porsche was so thoroughly convinced that the turbo would be a slow seller, so certain that wealthy buyers would grudgingly acquire one purely to support the racing program, rather than because they genuinely wanted it, that they did not bother with one of the most basic considerations of a global product launch. The orders that subsequently arrived from markets expecting right-hand drive had to be turned away or redirected toward later production years, a problem that Porsche had never anticipated having, and that represented one of the most expensive correct assumptions in the company's history. The homologation that justified the entire project arrived in December 1975, a date that might appear to be bureaucratic record-keeping but actually represents one of the most consequential moments in motorsport history. When the FIA granted homologation, they unknowingly released a competitive monster that would dominate racing for years and establish turbocharging as the dominant technology in performance motorsport for decades to follow. The homologation papers gave Porsche's racing engineers the license they had been waiting for with barely contained impatience. Group 4 and Group 5 regulations of the period allowed extensive modifications to competition vehicles as long as the basic engine architecture and fundamental chassis structure originated from a genuine production car. Porsche's engineers had been sitting on plans for wide-body racing versions, twin-turbocharger configurations, and aerodynamic modifications that made the street car look conservative by comparison, waiting for this single document to unlock everything. The 934 that emerged for Group 4 competition was already shocking, but the 935 that followed for Group 5 became genuinely legendary in ways that permanently altered what racing cars were expected to look like and perform like. The ultimate evolution of the 935 concept, the car nicknamed Moby Dick by everyone who saw it, produced over 700 horsepower from a twin-turbocharged version of the flat six and could reach 220 miles per hour on the Mulsanne straight at Le Mans. That a car achieving those numbers could trace its fundamental architecture to a 1960s road car design was considered almost miraculous by the engineers who built competing machinery and found themselves being destroyed by it consistently. None of it would have been possible without those 284 street cars and the homologation document they purchased with their existence. Look, the official power output figures from the period require some interpretation to be properly understood. Rest of world market turbos officially produced 260 PS, which translates to approximately 256 horsepower in the measurement system most familiar to American and British audiences. Early United States specification cars dropped to around 245 horsepower thanks to thermal reactors and air injection pumps that strangled the engines breathing in compliance with increasingly strict American emissions regulations. But these headline numbers miss the point of what made the turbo extraordinary almost entirely. Period road tests noted with consistent unanimity the ferocious mid-range character that arrived the moment the turbocharger reached operating speed. Magazine testers across Europe and America discovered independently that peak power numbers measured on a dynamometer bore almost no relationship to how the car actually performed on a real road in real conditions. The power did not arrive politely and progressively in the manner that buyers of contemporary grand touring cars expected. It arrived all at once, without warning, with a violence that was simultaneously terrifying and addictive. Some testers described the experience as discovering that the car had been secretly replaced by something much faster and much angrier while they were looking elsewhere. The surge was so pronounced, so dramatically different from anything else available, that drivers who had extensive experience with Ferrari and Lamborghini products found themselves genuinely unprepared for what happened when the boost gauge needle moved. The official top speed of 250 km per hour, equivalent to just over 155 miles per hour, placed the turbo among the fastest production cars available anywhere in the world in 1975. But the number itself understates the achievement considerably. What made that top speed remarkable was not merely that it existed but that the car could reach it and sustain it with a composure and mechanical reliability that Italian competitors producing similar or greater peak velocities simply could not match. German magazine tests conducted on unrestricted Autobahn sections revealed something that the specification sheets could not capture. The turbo could cruise at enormous speeds without drama, without mechanical complaint, and without the creeping anxiety that something expensive was about to fail. Engine temperatures remained within normal operating ranges. Oil pressure held steady. The only limiting factor at sustained maximum velocity was fuel consumption that would make the owner of a large American motorhome feel relatively economical by comparison. Contemporary Italian supercars of the period were faster in some respects and slower in others, but virtually none of them could match the turbo's ability to cover ground at extreme speed continuously without requiring the kind of careful nursing that owners of exotic machinery had come to accept as part of the ownership experience. The turbo asked for respect and demanded skill, but it did not ask to be treated as a fragile object that might break if pushed beyond a comfortable threshold. It was built to be driven, hard and far, and it delivered on that promise in ways that permanently changed what buyers expected from high-performance road cars. Here is what most people do not realize about the wheel and tire package that Porsche specified for the original turbo, because it tells a story about engineering philosophy that extends far beyond the simple question of how wide the rubber was. The iconic Fuchs forged alloy wheels fitted to early 930s were not merely attractive period accessories. They represented some of the most advanced wheel technology available anywhere in automotive production during the mid-1970s. Forged from aluminium alloy using manufacturing techniques developed originally for aerospace applications, the five-spoke design was not chosen for visual reasons alone. The spoke arrangement provided maximum structural strength with minimum mass while simultaneously allowing excellent airflow to the brake assemblies mounted behind them. Porsche specified 7-inch wide wheels at the front and 8-inch units at the rear, dimensions that appear almost conservative by the standards of any subsequent decade but were considered seriously wide by the benchmarks of 1975. The offset of each wheel was calculated with precision to work correctly with the wider track dimensions without causing tire clearance problems or generating the kind of scrub radius that would make the steering unacceptably heavy or imprecise. The meaty rear rubber, 225 section tires on those 8-inch rims, was essential for transmitting the turbo's power to the road surface with any degree of control. A contemporary Chevrolet Corvette may do with 225 section tires all around, and here was Porsche fitting that width exclusively to the driven axle of a car producing significantly more power through a much narrower contact patch than a front-engined layout would have provided. The tire technology of the mid-1970s added its own significant layer of challenge to the turbo ownership experience, and this is a dimension that modern drivers who have only experienced contemporary rubber genuinely cannot appreciate without having felt it. 1970s tires provided nowhere near the lateral grip levels of modern compounds, and in wet conditions the gap between what a driver expected and what the physics would actually permit was dangerously wide. Those wide rear tires would break traction on a damp road surface with an ease that transformed every motorway on-ramp into an unplanned experiment in throttle modulation and opposite lock. The transition from grip to slip happened with minimal warning and required immediate, precise, and calm correction from a driver whose instincts were probably screaming at them to do exactly the wrong thing. Lifting off the throttle mid-corner in a 930 experiencing oversteer was not a survival strategy. The combination of rear weight bias, turbo lag, and the sudden removal of gyroscopic forces from the rear wheels created what engineers called lift-off oversteer, a phenomenon so well documented in the 930s ownership history that it became a defining characteristic of the car's reputation. Experienced drivers learned to manage it, to catch slides with smooth, progressive throttle inputs rather than panicked corrections, to use the car's behavior as information rather than as a threat. But inexperienced drivers who approached the turbo with the same casual confidence they brought to lesser cars regularly found themselves facing entirely the wrong direction with no clear memory of how they had arrived in that orientation. And this brings us to perhaps the most extraordinary single fact in the entire turbo story, the detail that Porsche's official communications have consistently treated with careful vagueness for reasons that become obvious the moment you understand what actually happened. The first road-going turbo ever delivered was not sold to a wealthy customer through the normal dealer network. It was not presented to an influential journalist or given to a racing driver as a performance evaluation tool. It was a one-off birthday gift, presented to Louise Peach in August 1974, months before the official production launch at the Paris Motor Show. Louise Peach was Ferdinand Peach's sister and Ferdinand Porsche's daughter, which made her automotive royalty of the most direct possible lineage. The car wore Carrera badging rather than turbo identification, creating a unique and deliberately ambiguous hybrid that predated the production model while concealing its true nature from anyone who might ask inconvenient questions about a car that officially did not exist yet. The vehicle was essentially a development prototype dressed carefully in Carrera clothing, carrying standard Carrera scripts on its bodywork but hiding the turbocharged engine beneath its tail in an arrangement that would have been immediately recognizable to any Porsche engineer but invisible to the general public. Why disguise the turbo badging? Because officially, completely and entirely officially, the turbo did not yet exist as a production vehicle. Porsche was still completing final development work, still refining production processes, still negotiating with suppliers about component availability for what they expected to be a very limited manufacturing run. Presenting a turbocharged car to a family member months before the official launch required a degree of plausible deniability that the Carrera badges provided. This carefully arranged birthday present revealed something important about the internal confidence levels at Porsche during the turbo's development period. You do not give the company founder's daughter a birthday present that might explode, catch fire, or embarrass the family name in ways that would echo through European automotive society for years. The fact that Porsche's engineers trusted the development prototype sufficiently to hand over the keys to one of the most prominent women in the automotive world speaks volumes about how advanced and how reliable the turbo program had become by the summer of 1974. The car's current whereabouts remain genuinely unknown, which adds a layer of mystery to an already remarkable story. Some researchers believe it survives in a private collection, possibly updated to full production turbo specifications at some point in its history and therefore no longer immediately identifiable as the unique vehicle it is. Others suggest it may have been returned to the factory at some point and either destroyed during development testing or quietly absorbed into Porsche's own museum collection under a different identity. What is certain is that somewhere, possibly sitting in a climate-controlled garage attached to a European villa, is a turbo that predates every other turbo, a birthday gift that wrote the opening sentence of one of motoring history's most remarkable stories. The existence of this car also raises questions that Porsche has never been particularly eager to answer publicly. How many other prototype turbos escaped the factory in the hands of family members, important clients, or racing drivers who needed early evaluation examples? The official production records account for the 284 1975 cars with reasonable completeness, but the period before official production began is documented with considerably less precision, leaving space for other stories that may never be fully told. The interior of the press launch car added another layer of period authenticity that has become one of the most sought-after details in the entire turbo restoration community. Porsche's press car at the official launch sported tartan seat centers, not leather, not the Alcantara that would become fashionable in performance cars during subsequent decades, but full Scottish plaid fabric in a black, red, and white pattern that looked simultaneously outrageous and completely right for the moment in which it existed. The 1970s were a different era in ways that extend far beyond automotive design, and nothing proves that quite as effectively as the decision by Porsche's interior designers to outfit their flagship performance cars press introduction example with upholstery that looked like it had been borrowed from a Highland Golf Club smoking room. The pattern was not selected randomly or as an act of whimsy. Porsche's designers chose a specific tartan colorway that complemented the car's sporting character while providing a period-correct visual warmth that pure leather could not deliver. The fabric was also genuinely practical in ways that the leather alternatives were not, providing better lateral grip during hard cornering that kept occupants positioned correctly without the constant subtle sliding that leather produced, and breathing more effectively during warm weather driving that kept the cabin comfortable during extended journeys. The press car's tartan interior exerted an influence on the turbo's subsequent reputation that extended far beyond those initial launch reviews. Journalists who experienced the car during its introduction remembered those seats with a clarity and affection that endured for decades, mentioning them in retrospective pieces written 20 and 30 years after the event as if the fabric had somehow captured the essence of the entire experience in a way that the mechanical details alone could not. The tartan became so completely associated with the authentic 1975 turbo experience that finding a surviving car with original unrestored plaid fabric immediately and significantly adds to its collector value and historical credibility. This is where it gets really interesting, because the tartan story connects to something larger about how the turbo was positioned and marketed across different global markets, and the badge engineering decisions that accompanied those marketing choices reveal the complex relationship between Porsche's engineering confidence and their commercial caution. United States market cars for 1976 and 1977 wore turbo Carrera badges, rather than the simple lowercase turbo script that European examples carried on their engine lid. The reasoning behind this distinction tells you everything about how Porsche's American importers understood their market at the time. Turbocharging in 1975 and 1976 was technology that most American car buyers associated with diesel trucks, aircraft engines, and industrial machinery rather than with sports car performance. The word turbo on its own communicated nothing positive or exciting to the majority of potential American customers who might otherwise consider spending serious money on a European sports car. Adding Carrera to the designation provided essential context, linking the new model to Porsche's established racing heritage, and giving salespeople a familiar reference point from which to explain what made this particular 911 different from and superior to everything else in the showroom. The badging decision also reflected the uncomfortable reality of emissions compliance. United States specification turbos produced measurably less power than their European counterparts, constrained by thermal reactors and air injection pumps that reduced the engine's breathing efficiency in compliance with American clean air regulations that were tightening rapidly during this period. The Turbo Carrera badge carried a faint suggestion of apology within its marketing confidence, a promise of heritage and performance intent even when the actual output numbers told a slightly less exciting story than the European specification delivered. The European lowercase turbo script carried its own very different kind of message, one rooted in the understatement that characterized Porsche's communication with buyers who already understood what they were looking at. There was no need to explain turbocharging to a German enthusiast in 1975, no requirement to reference racing heritage for an audience that had been following Porsche's competition activities with close attention for 2 decades. The simple, small, lowercase turbo lettering suggested confidence of the deepest kind, the assurance of a company that knew its product was extraordinary and trusted its customers to recognize that fact without requiring it to be spelled out in elaborate detail. Modern collectors obsess over correct badging with an intensity that sometimes surprises people outside the community, paying hundreds or occasionally thousands of dollars for correctly period-specified scripts and emblems. Some United States cars have been retrofitted with European turbo badges by owners who prefer the aesthetic understatement of the original European presentation, while others wear their Turbo Carrera identification with the pride of authentic period specification. Both positions are defensible, and both reveal something true about the car's complex identity across different markets and different moments in its history. Here is what most people do not realize about the ultimate significance of the 1975 Turbo beyond all the individual facts and specifications and stories. The car that Porsche built reluctantly, to satisfy a minimum production requirement for a racing program, and then sold with genuine anxiety about whether anyone would actually want it, became the foundation upon which the entire modern Porsche brand identity was constructed. Every turbocharged Porsche that followed, the 930's successive evolutions through the 1970s and 1980s, the extraordinary 959 that defined the supercar template for an entire generation, the 993 and 996 and 997 and 991 turbos that each redefined what turbocharged performance could mean in a road car, and the current 992 Turbo S that produces 750 horsepower while remaining genuinely usable as daily transportation. Every single one of these machines owes its existence to the decision made in the early 1970s to build 400 homologation specials for a racing program that the street car subsequently overshadowed entirely. The 930 that emerged from that decision went on to production that extended until 1989, a 14-year run that saw continuous development and improvement while the fundamental character established in 1975 remained recognizably intact throughout. The whale tail, the turbocharged flat six, the dramatic on-boost performance, the demanding driving experience that rewarded skill and punished complacency, all of these things persisted through every revision because they were not marketing constructs or styling exercises. They were the authentic character of a machine that had discovered what it was by being driven by real people on real roads in real conditions, and that character proved durable enough to survive a decade and a half of evolution without losing its essential nature. The racing success that the homologation program enabled vindicated Porsche's engineering decisions in ways that no road test or magazine award could have achieved independently. Championships across multiple categories, endurance victories at events that tested machinery to its absolute limits, and lap records at circuits around the world proved that turbocharging was not a gimmick or a shortcut but a genuine engineering advance that the future of performance motoring would be built upon. Porsche arrived at that future first, with a car that had been conceived as a minimum-effort compliance exercise and became instead a maximum-impact statement about what was possible when engineering ambition met commercial success in the same vehicle simultaneously. The 934 and 935 race cars that the homologation unlocked dominated their respective classes with a completeness that embarrassed manufacturers who had been competing seriously for years. The knowledge accumulated through racing fed back into road car development in a continuous loop that made each successive turbo better than its predecessor while remaining true to the character that the original had established. What started as reluctant compliance with homologation regulations became the template for Porsche's identity as a manufacturer, a company defined by the relationship between road car excellence and racing program success, each feeding and justifying the other in an arrangement that has proven more durable and more commercially successful than anything Porsche's planning department could have projected in 1974 when they were quietly terrified that 400 cars might be too many to sell. Sometimes the best plans are the ones that fail to work out as intended, replaced by something better, stranger, and more significant than anything the original intention could have produced. The 1975 Porsche 911 Turbo is the definitive proof of that principle, a machine that became a legend precisely because nobody planned for it to become one. That is all for today, and if you made it this far, you already know you are exactly the kind of person this channel exists for. Subscribe so you do not miss what comes next, drop a comment telling me which of these facts genuinely surprised you, and give this video a thumbs up if the story of the car that changed everything was worth your time. See you in the next one.